Let's discuss a question from thermodynamics. It's from psychometry. Saturation pressure of water at 35. So it's Psat at 35 degrees Celsius is given as 5.6 kPa kilopascals, and for the sample, so you have taken now a sample of ambient air at 35 degrees Celsius. The relative humidity, which we denote as phi, it is 75%, so 0.75, and a standard atmospheric pressure. So the total pressure is the 101 kPa. The total pressure, which I called it as, because that standard atmospheric pressure is, if you measure the complete air, it's total, it's combining water vapor as well as the normal air, dry air. Now the amount of moisture in kg per kg of dry air. So what is asked is, per kg if you take of dry air, how much is the vapor content. So this is denoted by omega, which is basically mass of vapor by total mass of no, it's not total mass. Remember, that's should be uh, that should go no noticed. The specific humidity, it's basically the amount of moisture by amount of dry air. So mv by ma, it's not mv by m total. So this mv, now both we model it as ideal gas, both the dry air as well as the water vapor we model it as ideal gas. So we can use pv as mrt for both. So when you use PV by MRT for the vapor, it will be PV by some volume by R of water vapor, which is for H2O. This is in the numerator, and in the denominator the same equation, because both you are modeling as ideal gas. So PAV by R of air into T. Now the temperature will be same because it will be a homogeneous mixture. So both thermal equilibrium will be attained. So temperature term will be same. The volume term will be same because both are gas, so both will occupy the same volume in a given volume. Both the gas will occupy same volume. So it basically boils down to RA by RV into PV by PA. So this is the formula. Now RA is basically 28 point, I mean, okay, now RA is another thing. Like, how do you compute RA? Now these are the gas constants. So let's write down clearly here. And though I'm taking a lot of time here, you can directly, I can substitute the formula, but I just want to make a point here. I want to derive the formula from the basic things. So RA by RB is the gas constants. So gas constant of any gas, let's say of air, you can know by finding out the universal gas constant by the molecular weight. So universal gas constant is 8.314 kilojoules per mole Kelvin by molecular weight. The molecular weight of air is around 28, and similarly for the water vapor, it's same thing, universal gas constant 8.314 by molecular weight, which is 18. So if I use these two in this equation, I get R. So it basically converts in the ratio of molecular weight of water. So 18 by 28 point, it comes out to 18.28 point. So this molecular weight will be 28 point, or roughly most of the time it is taken as 29 into PV by PA, and this 28 by 18 by 28 is written as 0.622 PV by PA. So this is the formula for um, the specific humidity in terms of pressure. So PV by PA. Now 0.622 PV by PA is the total pressure minus the vapor pressure. So total pressure is P, which is given as 101 kPa. Now PV we need to estimate. Now PV by the saturation pressure at that temperature is nothing but the relative humidity. So the relative humidity is given, the saturation pressure at that temperature is given. So PV is phi into Psat, whereas phi and Psat both are given. So if you substitute that is here, so it will be phi into Psat by 101 kPa minus phi into Psat. So now you have to just substitute the saturation value. So it is 0.622 into 0.75, and the Psat value is basically 5.6 by 101 minus 0.75 into 5.6. So I could have directly placed the formula, but then in an exam you should always, even if you forget, you should always able to derive this formula, and the starting steps I have already told you. From basic definition we have just derived the formula of specific humidity. So this is now again just calculation, and this comes out to a 0.027. So 0.027 kg per kg of dry air. So starting from the basic definition of specific humidity, we have just gone from basics and derived this formula of 0.622, and then we have substituted. Thank you.